All right, so let's take a look at derivatives of inverse functions. For starters, we need the composition f of f inverse of x. We should know that, right, these two functions, a function and its inverse, work to cancel each other out. So we just get x. This is going to be really useful if we try to take a derivative. So say we take the derivative of the left side. That should be equal to the derivative of the right side, but we'll get there in a second. So the derivative of the left side, right, this is going to be a chain rule. We have an outside function f and an inside function f inverse. So the derivative, if we kind of cut through, just cut to the chase here on the chain rule, so we have f prime, right, would be the derivative of the outside. We just leave the inside stuff alone, times the derivative of that inside stuff, which is really the goal of this section. So we don't know what that looks like, but that's totally fine. We can say that it's d dx of f inverse of x. Now, the nice thing is, again, this is the derivative of the left-hand side here, and the derivative of the right-hand side is just the derivative of x, so it's 1. Right? Well, these two things are supposed to be equal because the original equation, right? If these two sides are equal, the derivatives are equal. So we have these two pieces. Let's set those equal. So f prime of f inverse of x times the derivative of f inverse equals 1. So we're just setting those two sides equal. And if we want to isolate this derivative of the inverse, we do something super fancy. We just divide this to the other side. So it's 1 over this f prime of f inverse of x. And that's the formula that you get for any inverse function. You can find its derivative. We'll do a couple examples after this.